Welcome back, students. Today we're starting Chapter 2, and Chapter 1 was all about review of pre-calculus topics, but Chapter 2 is actually calculus, so it's time for us finally to start learning some calculus. I'm excited too. So the first thing we learn about in calculus is the topic of limits. Limits are the foundation of calculus, and limits can be a little bit intimidating. They're a little bit abstract. What I want to do is refer you back to what we learned in pre-calculus when we were studying rational functions, and we did a little bit of work to familiarize ourselves with limits. So first of all, looking down here at the bottom of the page, I want to remind you what this notation means. If you see the notation limit of f of x as x approaches infinity equals L, that means as x gets infinitely close, or maybe I'll say as x gets closer and closer to infinity, that would be positive infinity, f of x gets closer and closer to the number L. So L would be a y value, that would be the height of the function. It's getting closer and closer to that height. You can say it gets infinitely close to L. I just didn't want to say infinitely close to infinity because I thought that sounded a little confusing. We also have one-sided limits. So look at the next one. The limit of f of x as x approaches 3 from the left, that little minus sign afterwards, equals L, means as x gets closer and closer to 3 from the left, so coming at it just from that side, f of x, which would be the y value of the point, gets closer and closer to L. And then similarly, if you have a little plus sign after your x value, x approaches 3 from the right. So this one means as x gets closer and closer to 3 from the right, f of x gets closer and closer to L. Calculus has a lot to do with infinity. Infinitely close to something, making a gap between things as small as possible, or things that are infinitely large. So let's take a look at this graph. This could have been some rational function that we graphed back in pre-calculus. You have a horizontal asymptote, you have a couple of vertical asymptotes, and then you have the curve here in green. So these 3 green parts, those all make up the function. We don't even have to know the equation of the function. In this case, we're just looking to evaluate some limits. So let's find the limit of f of x as x approaches negative infinity. So that means, what are the y values doing as we go infinitely far to the left? It looks like those y values are coming up close to that horizontal asymptote, and it's at a height of 1. So we would say the y values are getting closer and closer to 1. The next one is the limit of f of x as x approaches infinity. So as x goes further and further to the right, what are the y values doing? looks like over here they're also getting infinitely close to that horizontal asymptote, so they're getting infinitely close to 1. The next one is a one-sided limit. What is the limit of f of x as x approaches -2 from the left? So this is the negative sign and this is the from the left sign. So here's -2. What I want to do is come closer to it from the left, which means I'm following this curve. As x gets closer to -2, the y values are going down infinitely far. So the value of the limit is -infinity. What about the limit as x approaches -2 from the right? So that's the negative sign and that's the from the right sign. So still -2, but we're getting closer and closer to it from the other side. What are the y values doing? They're also going down toward -infinity. The next one is another one-sided limit, the limit of f of x as x approaches 3 from the left. So we're talking about +3, but we're coming at it from the left. So looking at the function, the y values are going up toward +infinity. And then we have one more one-sided limit coming toward 3 from the right. What are those y values doing? Here's 3, but we're coming at it from the right. The y values are going up toward infinity. So we have just evaluated all of those limits. Here's another one. Notice that this graph also has some holes in it and some jumps. So we're going to go ahead and evaluate some limits, starting with the limit of f of x as x approaches -infinity. So once again, we're going this way with x. What are the y values doing? Well, it looks like they're just going up, so it looks like they're going up toward infinity. I'll go to the one below it, the limit of f of x as x approaches infinity. So the x values are going infinitely far this way. What's happening to the y values? Looks like they're going down toward -infinity. Moving on, the limit of f of x as x approaches -5 from the left. So here's -5. Come at it from the left. What's happening to the y values? Looks like they're getting closer and closer to a height of 1. Now because there's an open circle there, they don't actually reach 1, they just get infinitely close to 1. And that's okay. A limit is not about what you actually reach. A limit is about what you're getting close to. So, I don't know why that turned out slanted. We're getting close to 1. What about -5 from the right? So we're going toward -5, but coming at it from the other direction, we're still getting close to a height of 1. What about +4 from the left? So here's +4. We're coming at it from the left, and it looks like those y values are getting closer and closer to a height of -2. They actually do reach -2, but that's irrelevant if you're just talking about limits. All you care about is what you're getting close to, whether or not you actually get there. And then we also have the limit as x approaches 4 from the right. Well, we're up here. When we're approaching 4 from the right, the graph is going up toward a height of, looks like about 3. Doesn't actually reach it, but again, it doesn't matter. It's just what it's getting close to. Now, 4 of these limits were one-sided limits. That's what the book calls them, one-sided limits. Those are limits from the right or limits from the left. They can also be called right-hand limits, or excuse me, they can also be called upper limits if you're going from the right, or they can be called lower limits if you're going from the left. So the right-hand limit in general would be the limit of f of x as x approaches a plus, and then the left-hand limit, the limit of f of x as x approaches a minus. Okay, we have a lot of things that we like to define in calculus, and what I like to do is give you the formal definition. I think that's my responsibility, to give you the mathematical accurate definition, but I also like to give you a casual version of the definition, which is kind of what we understand better. So, the casual definition of a limit. A limit tells you what the y value is approaching as the x value, sorry if that didn't come out right, that was x value, gets closer and closer to a particular value. The formal definition of a limit. The limit of f of x as x approaches a is equal to L if we can make the values of f of x arbitrarily close to L by taking x to be sufficiently close to a. If you think about that, do you see that that is saying the same thing? We're trying to make f of x, which is y, arbitrarily close to some value as long as x is sufficiently close to a. Okay, so as x gets close to something, f of x gets close to something. Now let's look back at the previous slide. Remember how in the case of looking at what was happening to the left and the right of -5, they were both approaching a height of 1 from both the left and the right? That means the limit of f of x as x approaches -5 is 1. From both sides it was 1, so the limit is 1. But remember when we looked at what was happening as x was approaching 4? The left-hand limit was -2 and the right-hand limit was 3. So the limit as x approaches 4 from the left was not equal to the limit as x approaches 4 from the right. That means that we cannot say anything about the limit of f of x as x approaches 4 in general. If the left-hand limit is not equal to the right-hand limit, then we just have to say this limit does not exist. If you don't see a left-hand or a right-hand symbol, it just means from both sides. And if they're different on each side, then the limit does not exist. So if the limit of f of x as x approaches a from the left is not equal to the limit of f of x as x approaches a from the right, then the limit of f of x as x approaches a does not exist. Now there are other limits that do not exist because when you look at the formal definition of a limit, the number L technically should be a finite number. Which means if we get infinity there, infinity is not a finite number, technically that limit would not exist. So if we look back at our previous problem, remember this one? We said we got infinity because the y values were going up infinitely high, or this one, we got negative infinity because the y values were going down infinitely low. We could also say that those limits do not exist. Technically, they don't exist if you get infinity or negative infinity. If the limit of f of x as x approaches a equals plus or minus infinity, then the limit does not exist because L in the definition is a finite number. And we did go back to example 2 and we looked at cases of all those things. Okay, let's take a look at this example where not only are we evaluating limits, but we're also going to find some function values. We need to think about both of these things because sometimes we get confused if we're talking about actual function values or if we're just talking about limits. Remember, for limits, it doesn't matter if you actually reach that point, it's what you're getting infinitely close to. However, for function values, we're looking at the points themselves, closed circle points. So let's do those first. What's f of 2? So here's 2. It's not this. This is an open circle. It's not this. This is an open circle. It's this. So f of 2 is 4. What's f of 4? So here's 4. It's not this. That's an open circle. It's this. So that's 5. What's f of 3? Okay, it doesn't have to be literally a circle. It just has to be the point on the graph. So here's 3. Here's the point on the graph. It's at a height of 1. Now let's work on the limits. The limit of f of x as x approaches 2 from the left. Here's 2, but we're approaching it from the left. We're going up toward a height of 2. The limit of f of x as x approaches 4 from the left. Here's 4. We're approaching it from the left. We're going up toward a height of 3. The limit of f of x as x approaches 2 from the right. Here's 2, but we're approaching it from the right, following the curve. We're going up toward a height of 1. The limit of f of x as x approaches 4 from the right. Here's 4, following the curve, approaching it from the right. We're going up toward a height of 5. The limit of f of x as x approaches 5 from the left. Here's 5. Let's look at the curve. As we get close to that, coming from the left, we're getting close to a height of 4. We actually reach a height of 4, but that's irrelevant. Okay, next we're going to switch things around, and we're going to be given information about the graph. We're going to sketch it. Now there are probably many ways to do this correctly, like you might make yours curvy and I might make mine straight, but they have to meet all of these requirements. Let's start with the function values. These will be points that we'll plot. We'll make a scale here. Okay, plot the point -2, 2. Plot the point -1, 2. Plot the point 3, 1. And the point 4, 3. Now let's go for the limits. As x approaches -1 from the left, the y values are approaching 3. Here's -1. Coming at it from the left, we need to be going up toward a height of 3. So I'm going to put my pencil right here on this point and come up toward a height of 3 and make an open circle. Can't make a closed circle because I already had a closed circle, and we can't have two closed circles in a vertical line or it's not a function. So that one's done. The limit of f of x as x approaches -1 from the right is 1. So coming at it from the right, well, I suppose maybe I could just start here at this point, or somewhere over here, somewhere to the right of it, and we want to come up toward a height of 1. So I'm going to make this crazy. I'm going to make it curvy and doing all kinds of things. It just has to get to a height of 1 by the time it gets there, or at least close to a height of 1. So you might have just made yours straight. Could be horizontal, straight across. It just has to be a function, but you can have some fun with functions. The next one, the limit of f of x as x approaches 3 from the left is 3. So here's x equals 3. Uh-oh, I'm going to have to undo what I just did because I have to be going up toward a height of 3, so I shouldn't have connected to that point. So that's okay, we can undo that. We need to be going up toward a height of 3, which is here. So I'm just going to connect my fun curvy thing to that instead. And then as x approaches 3 from the right, f of x approaches 5. So here's 3. Coming at it from the right, we could start at this point here. We have to go up toward a height of 5. 1, 2, 3, 4, 5. We could do this. So once you have those, you can just kind of go through your list again and make sure that you satisfied all the requirements. All right, this lesson is almost done. So there are 3 ways to evaluate a limit. Graphically, which we've been practicing so far today. Numerically, which we're about to do, using a calculator actually to help us. And then also algebraically, but we're not doing algebraically today. We're saving that for another day. Okay, so here instead of having an f of x, I have the function in that spot. So maybe it was f of x equals x squared minus 4 over x minus 2. So that's just substituted in there. We want to know what's happening to the function as x gets close to 2, from both the left and the right. We want to know what the y values are doing. So numerically, you see I have a table here, and I have I have x values that are getting closer and closer to 2 from the left. They're smaller than 2. And I have x values that are getting closer and closer to 2 from the right. These are greater than 2. What I'm going to do is put this in my calculator and evaluate these values. And we'll see what they're getting close to. So, you go to your calculator, you go to y equals, I'm going to put parentheses around my numerator, so we had x squared minus 4 divided by, and then parentheses around my denominator, x minus 2. I'm just using my table right now, so I'm going to go into Table Set, which is second window, change independent to ask. That way you can type in your own x values. And then second graph takes us to table. So we had 1.9, 1.99, 1.999, 2. Notice there's an error, and that's because 2 is not in the domain of that function. So something else is happening, but there's not a point on that function at x equals 2. Coming at it from the other side, we had 2.001 was the closest one to 2, 2.01 a little farther away, and 2.1 a little farther away. So look at what these y values are doing. From the left, they're getting closer and closer to what? That's right, 4. And from the right, they're getting closer and closer to what? Also 4. Okay, so we can put those numbers into the table. And our job here is to evaluate this limit. So what do you think the y values are getting close to as x approaches 2 from the left and as x approaches 2 from the right? Even though it doesn't actually get to 4, they're getting closer and closer to 4. So that is the answer for that limit. This is just a squiggly. For verification, look at the graph on the calculator. Okay. So I'm going to go to Zoom Standard, Zoom 6. All right. Could it be that this is just a line? Well, if we think back to our function, and if we factor the numerator, you know, this is a rational function, but it has the same factor on the top and the bottom, and when we cancel that factor, all we're left with is f of x equals x plus 2. That's the line y equals x plus 2. However, because of canceling those factors, there's a hole at x equals 2. So the hole is at 2, 4. So what we should be seeing is a line with a hole in it. Now, we don't actually see that hole in this particular view, but if I do a different zoom, like a zoom decimal, let's see if that makes a difference. Oh, up there, do you see there's a hole? Or if I do zoom square, same thing, there's a hole up there. Or if I do trace, and I type a 2 and press enter, notice at the bottom of the screen there's no y value. That's because of that hole. Okay, last problem. Same idea, different function. This would have been something like f of x equals sine of x over x. Something that we're not familiar with. We're going to find the limit as x approaches 0 using a table, putting in numbers that are getting closer and closer to 0 from the left, and numbers that are getting closer and closer to 0 from the right. So let's do that on the calculator. Clear out the function that was there. This is sine of x divided by x. In calculus, our default is radians, so I'm going to check the mode of my calculator and make sure I'm in radians. And then we're using the table again, so second graph takes us to table. Don't want these values, but we can just type over them. So we can delete them if we want to. For some reason, it's not. Oh, there we go. We can delete them if we don't like looking at those old values, or we can just type over them. So we have negative 0.1, negative 0.01, negative 0.001, 0. Okay, the function's undefined there because we don't want to divide by 0. Then we have 0.001, 0.01, 0.1. What does it look like the values are getting close to? In fact, if I put my cursor over those values, you'll see they're not really 1. They're just decimal numbers that are very, very close to 1. So we have 0.9983, 0.9999983, 0.999999983. Those are getting very close to 1, and the same thing is happening from the other side. So what's our conclusion about this limit? It equals 1. And then we can fill those numbers in. I think it was something like this. And finally, for verification, let's look at the graph of this function on the calculator. So here we have the graph, or the function. I'm going to do zoom trig, number 7. Okay, that should kind of remind us of a sine graph in a way, but it's not quite a sine graph because of dividing by x. And look what we have here. It looks like from the left and from the right, as we get closer and closer to x equals 0, we're getting close to a height of 1. However, if I press trace, type in x equals 0, there's no y value because there's a hole there. Okie dokie. So that was your first lesson on limits. Here's your homework, and a couple of them maybe have directions that are hard to understand, so I've tried to clarify that for you there. Thanks, everybody.